bottleneck resource usage can affect our decision. Just in case you have forgotten, this is the problem. We are making two products requiring operation at 4 different machines or processes, and we have 40 hours of processing time available per week. Process A required 12 minutes, 7 minutes, 16 minutes, and 10 minutes per unit at W, X, Y, and Z, and required 3 components, so 15 plus 11 plus 10, which they add up to $36. Selling price is given to you as $85 and demand per week is 70. And similar information for B. You will notice there are 2 components, 45 and 11, which is $56, and you need 16 minutes, 22 minutes, 6 minutes, and 10 minutes respectively. And notice I'm adding 2 Y operations into one. 16 plus 6 is 22. And again, the selling price and demand per week is given to you. Okay, so the same information has now been put in this table in Excel spreadsheet. Notice these items, A and B, their demand, and you will notice all the times, which I have just put them here. Now obviously the best thing is if you can make all 70 A's and 80 B's. The trouble is that if we figure out the total time that is needed to make all of these items, 70 A's and 80 B's, is going to be 70 times 12, which is 840, 70 times 7, which is 490, 70 times 16 is 1122, and so on. And you do the same thing for B, and you add up the times, and you will notice that you're good on all but the process Y. That's because this requires a total of 2,880 minutes, which you don't have. You have only 40 hours, and you know that 40 times 60 is 2,400 minutes. So you have only 2,400 minutes available. You don't have enough time to make all of A's and all of B's. So you must decide what is the most efficient way to use the bottleneck. So let's look at this particular table out here. You'll see that 2 items, A and B, prices are this much, $85 and $110 per unit. Raw material, if you recall from our diagram, were respectively $36 and $56. And the labor, this is the interesting one. Double click on this labor and you will notice that labor cost is basically $15 per hour. And for each item, I'm just going to add up these 12, 7, 16, and 10 and multiply that by $15 and divide it by 60 to, convert minutes into hour. And that number is $11.25 and $13.50 in the similar fashion. Again, this is basically add these numbers up. These are the amount of time you need in minutes at each processes. Divide that by 60 and multiply that by $15 to get the labor price. And then you subtract $36 and 11.25 from $85 and you'll get $37.75, and similarly 110 minus 56 minus 13.5 will give you $40.50. Now is the tricky part. This is the part where we have to say which of these 2 items is using the bottleneck resources most efficiently and therefore generating more contribution per minute of bottleneck usage. So what we do is we basically look at the contribution, 37.75 and 40.25, and divide them respectively by the number of minutes used per unit to make A and B respectively, which are 16 and 22 at the bottleneck. So 37.75 divided by 16 will give you $2.35. That means you are generating $2.35 of contribution per minute of resource Y for making item A. And for item B, you are generating $1.84091 per minute of bottleneck resources. That clearly tells you that you are generating more revenue per bottleneck usage for item A, and it makes sense to make all of item A before you make item B's. Obviously you can't make both all of A's and all of B's because you don't have enough time available. So you've decided that you will make more of item A, all of item A, because that's generating more revenue per minute of bottleneck usage. So you make all 70 A's, it will eat up 1120 minutes. How do I know that? Well, we know that it takes 16 minutes per unit. 16 times 70 is 1120. By the way, we had done that calculation earlier. 16 times 70 gave you 1120. And if you did that, you will be left with 1280 minutes for making B's. How do I know that? 1120, if you subtract it from 2400, will give you 1280. So now you take this 1280 and divide that by 22, because this is the amount of time you are left with in bottleneck department. Why? If you divide it by 22, that will tell you how many units of B you can produce. So I'm going to just come here and enter this number, equal to, write this formula down, which is this, divided by this number, and that will give you 58.182. But you know you can't make fraction of a product here. So what you do is, it should be 58 here. Okay, that's the answer, and basically tells you can make 70 A's and 58 B's, and total contribution is going to be this is basically again 70 times 3775 and 58 times 48.50. That is sum product, this comma this, and that's the answer. Hopefully this helps you remember or recollect what we did in class, and hopefully you'll find it useful. Thank you.